Welcome back to Skyward Space Quest, where we explore the mysteries of our solar system and beyond. Today's journey takes us over 2.9 billion kilometers from the Sun to one of the most bizarre and overlooked worlds in our cosmic neighborhood. A planet so strange, it spins on its side with seasons that last decades. A planet with faint, eerie rings and moons named not after gods, but Shakespearean characters. A place so distant and cold that sunlight takes nearly 3 hours to reach it. This is not just another gas giant. This is Uranus, the tilted enigma of the solar system. What caused its unusual spin? Why is it so cold? Colder even than Neptune, the outermost planet. And why are scientists calling it the top priority for a new space mission? Over the next 15 minutes, we'll explore everything from Uranus's structure and atmosphere to its dark rings, frozen moons, and the lone spacecraft that ever visited it. So strap in. This is the full story of Uranus, the planet that shouldn't exist the way it does. Uranus is the seventh planet from the Sun, orbiting at a distance of roughly 2.87 billion kilometers. That's nearly 19 times further than Earth. Light from the Sun takes 2 hours and 40 minutes to reach its upper atmosphere. It's massive, with a diameter of about 50,700 kilometers, making it the third largest planet in the solar system by size. But in terms of mass, it ranks fourth, smaller than Neptune despite appearing larger. Now here's where things get interesting. Unlike Jupiter and Saturn, the traditional gas giants, Uranus belongs to a different class, the ice giants. What's the difference? While gas giants are composed mostly of hydrogen and helium, ice giants like Uranus and Neptune contain a much larger proportion of elements like water, ammonia and methane. These are considered ices in astronomical terms, even though they may exist as superheated fluids or slush deep within the planets. This chemical makeup gives Uranus its soft blue-green color. The methane in its upper atmosphere absorbs red light and reflects blue wavelengths, producing a tranquil teal hue that belies the planet's turbulent history. But beneath this serenity lies something deeply wrong. Its axis of rotation, the imaginary line around which the planet spins, isn't vertical like Earth's or even tilted like Mars. Uranus is tipped over completely. It spins almost perfectly on its side, a phenomenon not seen in any other planet in the solar system. Let's dive into what that means and why it's one of the strangest things about this frozen world. Earth has an axial tilt of 23.5 degrees. That's what gives us our seasons. Saturn, about 26.7 degrees. Mars, around 25. But Uranus, 97.77 degrees. That's not a tilt, that's a topple. Its equator is nearly perpendicular to the plane of its orbit. From space, it looks like a wheel rolling along its side. This extreme tilt means the poles of Uranus point almost directly toward and away from the Sun during different parts of its orbit. As Uranus takes 84 Earth years to complete a single orbit, each of its poles spends 42 years in daylight, followed by 42 years in darkness. In other words, one season on Uranus can last decades. And that raises a fascinating question: what could possibly cause an entire planet to fall sideways? The most widely accepted theory is that during the formation of the solar system, Uranus was struck by a massive object, perhaps 1 to 3 times the mass of Earth. This catastrophic impact could have knocked the young planet into its current rotational state, realigning not just its axis, but possibly its interior layers, magnetic field and thermal structure. New simulations suggest that this impact may have created layered shells inside the planet, like a cosmic onion, that prevent heat from escaping the core. That's one reason Uranus is so cold. But we'll come back to that. Now, imagine standing on one of Uranus's moons during its long polar night. The planet wouldn't rotate overhead. It would slowly spin around you like a spotlight in the dark. This sideways spin isn't just strange, it's astronomically unique. And it affects everything about Uranus, from the behavior of its weather systems to the structure of its magnetic field to how it's viewed from Earth. Let's play with a thought experiment. What would happen if Earth had Uranus's tilt? That means, for part of the year, the North Pole would point directly at the sun, bathing the Arctic in constant daylight. Cities like London or New York might experience months of non-stop light, followed by months of pitch-black night. Meanwhile, the equator would face extreme variations in sun exposure. Some areas might go from scorching hot to freezing in a single season. Weather patterns would collapse, agriculture devastated, and life, at least as we know it, would likely not survive. Thankfully, Earth's tilt is modest, but Uranus is the wild card, the world that broke the rules of planetary rotation. Uranus isn't just tilted, it's also, well, absolutely freezing. In fact, it holds the title of coldest planet in the solar system, with recorded temperatures dipping as low as -224 degrees Celsius, that's -371 degrees Fahrenheit. What's strange is Neptune, the eighth and final planet, is actually farther from the Sun, but it's warmer than Uranus, so what's going on here? One theory is that Uranus simply doesn't release much internal heat. All planets trap energy from their formation, a kind of leftover furnace from billions of years ago. Jupiter, for example, radiates twice as much heat as it receives from the Sun. Neptune does the same, but Uranus? It barely emits any excess heat at all. It's like a cosmic thermal anomaly. Some scientists think that a massive collision early in its life not only tilted the planet, but also disrupted its internal layers, creating barriers that block heat from escaping. It's as if Uranus is wearing a thermal blanket, locking in the cold. Above that icy interior lies a thick atmosphere, made mostly of hydrogen and helium with methane, the chemical that gives Uranus its lovely teal hue, making up just 2%. Despite its quiet appearance, Uranus does have weather, including high-altitude clouds, swirling wind bands, and the occasional violent storm. The winds? They can reach up to 900 kilometers per hour. That's, well, faster than a Category 5 hurricane on Earth. In 2014, the Hubble Space Telescope captured massive white storm systems developing across Uranus's surface, likely triggered by changes in solar exposure as the seasons slowly shifted. It's a reminder, even a frozen world can have an active sky. Rings aren't just for Saturn, you know. In 1977, astronomers got quite a surprise when Uranus passed in front of a distant star. As they watched the star flicker, it disappeared 5 times before the planet arrived. And again as it moved away. This wasn't a glitch, it was evidence of a ring system. Today we know Uranus has 13 known rings, thin, dark, and rather difficult to spot with traditional telescopes. Unlike Saturn's bright icy rings, Uranus's rings are made of dark carbon-rich particles, possibly the remnants of shattered moons. Most are just a few kilometers wide. The brightest ring, called Epsilon, is oddly sharp and narrow, with defined edges likely held in place by shepherd moons. And get this, some of the rings are eccentric, meaning they're not perfect circles. Others are inclined, tilted slightly from the equatorial plane. These are rings shaped by chaos, not symmetry. In 2007, the Hubble telescope discovered 2 new outer rings, bringing the total to 13. These distant rings are redder in colour, unlike the grey inner ones, a sign they may be composed of different materials or formed later in Uranus's history. Altogether, Uranus's ring system is dim, dusty and delicate, more like a whisper than Saturn's shout, but hauntingly beautiful nonetheless. Uranus has 27 known moons, and in a break from mythological tradition, they're named after characters from Shakespeare and Alexander Pope. Let's meet the most fascinating ones, shall we? First, there's Titania, the largest of Uranus's moons, spanning over 1,500 kilometers across. It's believed to have an icy crust over a possible subsurface ocean and ancient tectonic faults crisscrossing its surface. Next, Oberon, second largest and most cratered. a dark world of ice and rock orbiting farther out with an eerie red tinge. Then comes Ariel, the brightest and geologically youngest. It has wide valleys and fault systems, suggesting past tectonic activity. Could it be a world that once shifted and cracked from internal pressure? Umbriel is the darkest major moon, reflecting little sunlight and showing an almost mysterious emptiness like a frozen relic untouched for eons. But the most bizarre? That's Miranda. Miranda is just 470 kilometers wide, barely the size of England, but its surface looks like it was shattered and glued back together. It has towering ridges, broken plains, and a cliff called Verona Rupes, possibly the tallest in the solar system, plunging up to 20 kilometers straight down. Miranda's chaotic surface suggests a violent past, either from tidal heating, massive impacts, or even orbital resonances that tore it apart and let it reform. Some moons may even have internal oceans, like Titania or Oberon, raising tantalizing questions about habitability. Are there warm pockets of water deep beneath the ice? Could Uranus's moons, like Europa or Enceladus, be future candidates in the search for life? We won't know until we go back. Only one spacecraft has ever visited Uranus, and it stayed for just a few hours. That visitor was Voyager 2, launched by NASA in 1977 with a mission to explore the outer planets. After flybys of Jupiter and Saturn, it reached Uranus on January 24, 1986. Voyager 2 passed within 81,500 kilometers of Uranus's cloud tops, gathering vital data as it zipped by at over 60,000 kilometers per hour. In that brief encounter, it really revolutionized our understanding of the planet. It discovered 11 new moons, confirmed the existence of rings, and revealed Uranus's bizarre magnetic field, tilted nearly 60 degrees from its axis and off-center by a third of the planet's radius. This magnetic field behaves unlike any other. As Uranus spins on its side, the field wobbles and corkscrews through space, creating wildly shifting auroras that don't neatly align with the poles like Earth's do. Voyager 2 also measured the planet's extremely low temperature, its fast winds and its relatively bland appearance, lacking the massive storms of Jupiter or Neptune. Yet despite all it showed us, Voyager 2 raised more questions than it answered. Why is Uranus's internal heat so minimal? How did its magnetic field become so chaotic? Do its moons hide oceans beneath the ice? What's happening in the planet's core? We've been waiting nearly 4 decades for a follow-up mission, and now it might finally happen. In 2022, the National Academies of Sciences recommended Uranus as the top priority for planetary exploration in the coming decade. The proposed mission, a Uranus orbiter and probe, possibly launching in the early 2030s aboard a powerful rocket like NASA's Space Launch System or SpaceX's Falcon Heavy. The plan? Send an orbiter to study Uranus from close range for several years and drop a probe into its atmosphere to collect data as it descends. This mission could reveal the internal structure of an ice giant, monitor its ring dynamics and weather over time, map the planet's magnetic field in detail, and study the geology and composition of its moons, especially Titania, Oberon and Miranda. With modern instruments, we'd get high-resolution images, spectral scans, plasma readings, and maybe even signs of habitability beneath the icy crusts. It would be a chance to finally unlock Uranus's secrets, not just for curiosity's sake, but to better understand exoplanets too. Because here's the twist, most of the planets we're finding in other solar systems, they're about the size of Uranus. Studying Uranus could help us decode the atmospheres and dynamics of ice giants across the galaxy. This isn't just a mission to a distant planet. It's a mission to understand a whole class of worlds we barely comprehend. What would it be like to fall into Uranus? You'd start by descending through the upper atmosphere, made of hydrogen, helium and methane. Temperatures would be around -200 degrees Celsius, and light would fade quickly. There are no solid surfaces, just increasing pressure. As you plunge deeper, The gas turns into supercritical fluid. Not quite a gas, not quite a liquid. Winds scream past at 900 kilometers per hour. The pressure begins to crush your spacecraft. Keep falling and you'd reach pressures over 1 million times Earth's atmospheric pressure, enough to destroy any probe we've built so far. Below that, possibly a slushy mantle of water, methane and ammonia, heated by pressure, swirling around a small rocky core. But no light, no bottom, just a slow, crushing descent into the unknown. That's what makes Uranus so compelling. We simply don't know what lies beneath, and we won't know until we go there. Uranus is not just the seventh planet from the Sun. It's a frozen enigma, a sideways spinner, a world with ghostly rings, shattered moons and untold secrets beneath its calm blue shell. It's the kind of place that reminds us how weird and wonderful the universe really is. As we push the boundaries of space exploration, let's not forget the planets we've barely begun to understand, like Uranus. Thanks for watching Skyward Space Quest. If you enjoyed this deep dive into the unknown, give us a like, subscribe and tap the notification bell. We've got many more cosmic mysteries to explore. Until next time, stay curious.